Okay, this is the 08120 exam walkthrough. I've just finished marking all the papers, and as a kind of social service, I, I think it's worth going through the actual answers at this point so that anyone that's done the exam can have a look at what they did and how it went and stuff like that. And I'm at the moment, having done 140 or so marking exercises, I'm pretty well calibrated on what people said that was sensible and what people said that wasn't. Okay, so thanks to Mike for lending me the handset, and let's go and start straight in. Question 1, Part 1A. So we have a class here called account, which has got a couple of things in it: minimum customer age and max customer age. And it says explain why two data members have been made private. This is an easy 2 marks, and pretty much everybody got this one. Basically, you make things private because you don't want someone to fiddle with them. So if you said something along those lines, you get one of those 2 marks. If you said it was to stop programs which aren't part of the account class, that's classes that aren't the account class, being able to fiddle with these numbers directly, that gets you the other mark. If I make something private, which is what's happening here, then what that means is that it's not visible outside the class. Methods in the account class can play with minimum and maximum customer age, but methods outside that class can't because they are private. So they've been made private to protect them, and more specifically, so that programs outside the account class can't fiddle with them. So that is 2 easy marks. Away you go. We need to hold the age of each account. Okay, this is 1B. A type that you might like to use, and the C# code for a method validate age that can be used to actually look after these values and validate them. Now, quite a few people got hold of the right end of the stick and did this perfectly. 1 or 2 didn't though, so let's make sure that we fully sorted on what we're going to be doing here. One important thing: make sure that when you get a question like this, you do all the things the question asks. And if you're not sure what to do, read the question again, and probably again, until it makes sense. In this case, we're after a C# data type, and since the maximum and minimum have been expressed as integers in the previous part of the question, then it seems sensible to go for int. So pretty much everyone said it's integer because that's how we store ages. 1 or 2 people said it's unsigned because the idea of a negative age involves time travel, which is not really on, and so int or unsigned int is fine. Anything numeric, basically. And so people just said we should store the age as an integer. That gets them a mark or 2. Then we can move on to validate age. Now, lots of people had different ideas on this, which is fine. Anything which looked like it would work got sensible marks. The thing to bear in mind is that what the question's asking for is a method called validate age. So you really should write a method at this point because that's what it's asking you for. The method will be called validate age, and it will let me tell whether or not an age is valid. Now, if you're asking questions like, is this okay or not, then the standard way of responding is true or false. So what you'd be aiming to produce in this particular piece of the jigsaw, if you like, is a method which accepts an age and says, yep, that's a good one, or no, that's a bad one. That's what we're after, and I've rather conveniently given you a couple of variables at the top: min customer age and max customer age. There they are, which we can use to this. So I can now play with some code. Let's play with some code. So I get hold of my account class and I just copy it out of there, and I go into here and I make myself a new project which we'll just call exam fun. Let's make it a Visual C# console app. There you go, and we'll just call it exam fun because we're having fun with exams, aren't we just? And I will drop into my program a class called account, which will probably, there you go, there's my account class fresh from the exam. Okay, it wants a validate method, and this is how I write it. First thing, is it public or private? Well, if it's private, it's great, but nobody else can use it. It's quite often the case that you might want other people to be able to use your method. So I reckon it's going to be public. What's it going to be called? Let's go back and have a look. It's going to be called, let's go find, oh, stop doing that, Windows 8. It's called validate age. There it is. So we'll call the method validate age. and we'll go back to Visual Studio and we'll make it make a method called validate age, and it's going to return a bool to indicate the age is okay. And if we're going to do that, we should give it an age to work on, which we could just feed in as the value age. Now, a version of validate age which was overly optimistic could return true every time. That would mean that everything is wonderful. There's no such thing as a bad age. We don't want that though. So we could write something that did this kind of thing, and there's various different variants. This is the one that I would tend to go for. If age is less than min customer age, can't type today, then what do we do if it's below the minimum? We return false. If the age is, and I think what's coming next, is greater than max customer age, then it's still bad and we return false again. Otherwise, if it's got past those two tests and it's okay, we return true. So this would be a pretty much a perfect solution. There's only one way that I could improve on this, and that's at the moment I have to have an account to ask, hey, is this age okay? If I want to basically just take a number and see if it will be a sensible age or not, I need to make this method static. What that means now is it's part of the class. More on that a little bit later. And it means it can be used just to, so I can basically get an age in here, int, what is, well, we can just go something like if validate, I can't type day, count dot validate age. Let's see if 150 is a sensible age. Console dot write line. Program is broken. Why is program broken? Because if it reckons the age of 150 is valid, then there's something not quite right. So I can run that, and that's a little test, if you like, to prove that my program's okay, because as we can see here, the maximum customer age should be 90 and the minimum customer age is 18. My little method does that test, and so this, if you put anything like this in your program, actually would have got you full marks. Some people put things in here like write line age too low, you see, like that, thinking that was a good thing to do. Actually, in this particular context, it isn't, because these little methods are really only supposed to return whether or not the age is valid, not actually talk to the user. This might be happening deep in the bowels of a server somewhere on the interwebs, where there's no user to even see a message. So the validate age method should just return true or false, and then if I want to, as I have done down here, I can use that to then return I can use the return value to decide what method or what message to show. Okay, so that's question 2, part 2 of question 1. Let's go back to the questions. And so there you go. Let's put it in an int, and let's write a method called validate age, and that would have got you 5 marks. And on with the motley. That's all looking splendid. Okay, the static question. 1 or 2 people did say static means you can't change it. Please don't do that. Static does not mean you can't change it. It means it's always there. The reason why we've done it is because we want these numbers to exist for the entire class and not for any particular instance. Things like minimums and maximums are values that you don't store on a per account basis. You store them once for everybody in the account class. Static means part of the class always there. So a couple of good answers for this one that would have got you the marks are, we want it so that everybody in the class can share the same minimum and maximum, but we also want it so that you can actually test the minimum and the maximum without actually making an instance of the account class. If you look at my code back in here, then you'll find that I've called this method validate age, but I haven't had to make any accounts. There's been no new going on. I've basically got a static value which tells me what the maximum age is, and another one tells me the minimum, and then I have a static method which uses just those 2 static values to do the test, which means that I can ask the account, hey, is this age all right, without needing to have any instances. So that's kind of why it's there. Anyone that put that was going to pick up a chunk O marks. Anyone that says they're there because it means they can't be changed, not going to end well. Very, very sorry. Really not going to end well. No marks for that one, I'm afraid. So there you go. Okay, so 1D now must hold the name of the account holder, held as a string, and their bank balance, held as a float value. So suggest appropriate data members to hold this information and state how the program will manage access. This is actually, again, all good, common, sensible stuff. Don't overthink these things. In this situation, I'm just storing the one account. I'm not storing lots of them. I'm not storing a huge number of bank customers. I'm just storing one of them. So if you sort of think in terms of, well, you've been told we're holding a name and a balance, why not have a member called account name or name and a member called balance, which is a float. So one of them's a string, one of them's floating point. And the thing I wanted really from this question is, what's the management of the data? How do we control who can do what? So if I go back to my code and I write something like, well, here we go. I could go public string customer name. Okay, that's not too bad. And also public float balance on my noisy keyboard. That's fine, except for the fact that now anybody in the world can fiddle with these. So a programmer could give himself £10,000 just by writing a program that got hold of the balance value and whacked 10,000 quid on it. So that's probably not a good way to do it. So quite a few of you, in fact the majority, said that should really be private, because that means that we can't actually fiddle with it without getting control. One or two said the name can be public because it's okay to change that. That's fine-ish. Although I wouldn't like it if someone changed the name of the customer to be empty string or ZZZ or dot dot or whatever, or squiggle or something like that. I'd like to have some kind of verification of the customer name before I store it. And if you make it public, you kind of lose that control. So I tend to prefer private for both of these. And then, as we've seen before, we'll have a public method. If I could type it. Void, if you like, pay in funds, and then we'll give it an amount here, and then in its simplest term we'll go balance equals balance plus amount to pay some money in. Now this isn't perfect. I wasn't asking for all this kind of stuff in the answer. What I was really after for this one was the name can be called holder name or customer name or something. The balance could be called balance. Those should be private, and we should have public methods to get and set to actually change those values. So what I was really after here is the public-private kind of action. The key phrase really is how it would manage access, because what I want you to be thinking about is that data should be private because it's special and protected, and methods should be public. And the methods can then get control when the data is being changed, and they can do sensible things with it. They can make sure that the data is in a valid range, and they can even do things like log stuff. So you can actually write things out into a log file to detect when people have paid money in and drawn money out, which for a bank is kind of important. So public methods, private data, sensible names, 5 marks. So that again was quite an easy one. If you talked about lists and arrays and all kinds of stuff, then I would have raised 1 or perhaps 2 eyebrows at that, and it wouldn't have cost you a huge amount. As long as you're looking at how the data is managed and how it's stored, I'm quite a happy bunny, and we can move on to the next part of the question. So down we go a little bit further. I think it might be time for constructors, and yes it is. So when we make a new account, we're now thinking in terms of a way in which we can set the name of the account holder and their balance value. This makes extremely good sense, and we're going to have a signature for a constructor. Now the constructor is the method that runs when you say new. So if you go back to my sample code here, we can actually make a constructor for the account class, which we'll make public because otherwise it can't be used. And then in here we'll go string in. And I do it this way because this is my convention, float in balance. and whatever happens inside the constructor sets up the data in the customer, in the account, sorry. And quite a few folk had done this, and then you go things like customer name equals in name, and you go customer, and then you go balance. If I could type it, not going well today, equals in, and I've just realized I spelled balance wrong. Put the E on the end, Robert, in balance there. Okay, so that's how you set it up, and you put a semicolon there so everything lines up nicely. And so now in my main program, if I want to make myself a new account, I can just go account A equals new account, and I can give the name of Fred, and let's give Fred £1,000. Let's be generous. There you go, lucky old Fred. So Fred's got £1,000. Wonderful. So that's how it works. This bit here is the constructor, which is the name of the class, and we feed it a name and a balance. And if you just wrote that bit, then you're heading towards a good set of marks here. If you put the rest of the code in, that's fine too. But let's go back and have a look at the rest of the question, because there's more we have to say. We've got the constructor signature, the bit it takes in, the string and the float. Explain how a programmer can ensure that a program never creates an account which contains invalid data. Now, quite a few of you said you could use try catch, which is sort of okay, but the point about, and some of you said the constructor could display an error or something. The thing to remember about constructors, which is really important, that I want you to take away from this bit, is that they cannot fail. A constructor will always succeed. It always runs to the end, and when the constructor finishes, you have got a new instance of that account in your program. So the way we have to stop bad accounts from being made, well, one or two of you said let's give them default balances. Let's say if the balance is stupid, we'll make it 0, and if the account name is stupid, we'll make it empty string, which is fair enough and kind of works. But a better way is to make the constructor actually blow up. Well, not explosion type blower, but actually fail to run, actually stop executing if it gets given invalid data, because that's what you want. You don't want any accounts in your program that have actually got duff values in them. What you want is accounts that only ever have good values. So anyone that said the best way to stop making a bad account is to throw an exception, then you get the full marks. People that mentioned error checking and error returns got close to full, but for the full 7, I was really after you make the constructor throw an exception. I'll show you what I mean. So here I happen to have, if we go, if the customer name is empty string, if in name equals an empty string, throw new exception bad name. Okay, and we'll put that at the top, so I'll just move that up to there because I can. So now if I try, I cannot make an account that has an empty name. If I try and do this, if I try and run my program with an empty name in there, let's see what happens. Well, it goes quiet, never a good sign. And then we have an exception thrown, and my program actually crashes at this point. So the correct way to actually make sure in your constructor that bad things don't happen is actually to make the constructor throw an exception if it finds things it doesn't like. So that's how you get your 7 marks. That's part E. And the final part of question 1, reference and value types. It's just 6 easy marks. I am so kind to you lot. Basically a reference type, and lots of people wrote this, reference equals tag. So if you mentioned tags and drew little boxes with arrows going out of them and some boxes with numbers written inside them, which is the value types, then you're absolutely going to get your 6 marks here. This was a really nice gravy train type question, which you should have been able to jump on, and most people did just that. So basically reference types, examples of reference types, the account above it's a class, it's a reference type. Value types are things like structures, integers, floats, and all that kind of good stuff. So people really sort of went for this one and dipped their bread in. Basically I'm looking for little boxes with tags tied to them if they're references, and holding numbers if they're values. And what really does work well in these situations, and lots of people did it, is to show some C# code, x equals y, and then show in a diagram form what happens to the tag X when it's set to Y, which box is it now tied to, all that kind of stuff. So if you did that, then kudos, well done, and that would have got you 6 marks, and that brings us to the end, I believe, of question 1. Splendid. Okay, here we are with question 2. I say that question, I'm clapping my hands here, I'm so happy. I'm happy because everyone went, way, and dipped their bread in big time. Everyone went, question 2. Rob's not lied to us. Rob's given us a problem that's involved designing some classes, like he said he would, and off we go. That's absolutely fine. I was looking for everything in the right place to get the full marks, and I'm very pleased to be able to report that pretty much everybody sort of went, okay, this is fine, I know how to do this. We have boats that have a name, a date when they were launched, and a price to hire the boat for a day. So that's basically everything. All boats are like this. Sailboats are like boats but have a number of masts, an area of sail. Motorboats are the same as boats that have an engine which is either diesel or petrol, and a particular size given as a particular capacity, an integer. And then powerboats are like motorboats but can also tow a particular number of skiers. So we have this little set of 1, 2, 3, 4 classes. And what I wanted was a diagram that basically sets out how all this fits together. And everybody really went for this. And there was only one person, I think, that didn't actually draw a diagram, which is unfortunate because it asked for a diagram. So it said, draw a class diagram. And everybody put something like boat at the top, and everybody put powerboat at the bottom underneath motorboat. So we had the boat class at the top, which had a string name, a date, which some people put as a string or a number or a date time type. All those are fine. And then a price, which could be a float or a decimal or some kind of number. And then underneath boat they had sailboat, which was a descendant of that and contained an integer for number of masts and a float for the area of sail or whatever. And then motorboats come down under boats and have engines. Some people said the diesel petrol thing could be a string. Some people said it could be an enum. Some folks said it could be a bool. I was happy with any of those. Those were fine. And then the size, that's going to be an integer. And then down underneath underneath motorboat, you've got powerboat, and so you get a little diagram that looks quite nice, and everybody pretty much drew this. So I'm not going to draw one just now because, as everyone has seen me in lectures knows, my drawing is actually pretty rubbish. So there you go. So people drew this up, got 8 marks, and smiled and moved on. Make sure if you get this kind of question in the future to get a diagram, read the question, add all the bits. 1 or 2 people forgot to put the actual variables in and just drew the diagram, which was lost them a few marks. But generally speaking, yeah, it all went okay, and I'm happy with that one. And I got some nice designs. This one, however, a little bit more variation now. What I was really after here, the customer has told you they have 100 different boats. So what I want you to do is picture now a nice piece of calm riverside with a little shop, and next to that a little building where they repair the boats, and then outside this area or down the river are 100 different kinds of boats all in a row. We have some motorboats, we have some sailboats, we have some powerboats, and they're all in a little row, all tied up, beginning of the season, and the owner standing there with a big smile having his picture taken alongside all his boats. He wants to keep track of all his stock, and he's hired you to do this. So we have 100 physical boats that we want to actually think. Now, that's how it's going to be. That's what we've been hired to look after. And so we make a class called hire stock to store all these boats. And pretty much everybody, but not everybody, said what you really want here is a collection of some kind. And since I've said 100 boats, quite a few people said, oh, that's 100 inches. So we'll have, 100 element array, I apologize. And so we have an array of 100 boats, and each of them can be a sailboat or a motorboat or a powerboat, because that's how classes work. And an array element that contains a reference to a boat could refer to any of the child classes. So some folks said use an array, that's going to get you a good bunch of marks. Some folks said use a list, because lists are also a good idea. You could have a list that could grow in size if the guy buys his 101st boat to put on the riverbank next to his nice shop and his nice little area where he repairs them or what have you. Then in that situation, absolutely fine. We'll have a list which we can add one to, whereas if you have an array, it's kind of fixed size. And quite a few of you made that point, and that's nice. But the thing I really want you to take away from this one is it's called hire stock. It's actually going to be a totally separate class which just contains a whole bunch of boats. Some people said this should be the parent class of boat. That's not true. That's not right. The two things are distinct and separate. You're going to have this idea that a boat is the thing that you want to store, and hire stock is basically a container which contains a bunch of them. In terms of classes, they're not really related at all. It's just that one has a bunch of references to the other type in it. Okay, so we have the situation where we have a class called hire stock that contains a list or an array or some kind of collection. Some people said we could have three lists, one to hold the list of all the boats that are in for repair, one for a list of all the boats that are actually out for hire, and another list of boats which are available for hire. You could do that. That would work. That also got you full marks. One or two people also said you have a list of sailboats, a list of power boats, and a list of the other kind as well. I wouldn't be so inclined to go that way. The whole basis of the way that classes are designed means that you can have a list of boats and then have any type of boat you like in there. So as far as I'm concerned, that was a slightly less good answer. For me, the perfect answer was basically we're going to have an array of boats and they'll be inside there. If you want to improve on matters, then why not have a list? Then it can grow over time. So that's 5 marks, and lots of people got that too. At any given time, if you think about this little man with his lovely set of boats on the side of a river, it's sunny today, which is nice. The boats are looking fantastic. At any given time, one of his boats either being out used by a family for a cruising holiday, or it's actually in the workshop being mended, having its barnacles scraped off its bottom, or whatever it is they do with boats, or it's actually available, waiting on the side for someone to turn up and use it. So you've got 3 possible states. Explain how you would store this. There's a whole bunch of different ways you could do it. 1 or 2 people said use an well, actually quite a few. But the most popular way, if we're having a part of these things, was to use an enum, which could have 3 possible values. This is going to be 3 values which are maintenance, hired, or available, I guess, would be good names for those states. And we put that in the boat class so that every single boat can now have that particular state. That works fine. Some folks had a string, which would also work. Have a string which contains the word maintenance, available for hire, or out on hire. You could make that work. And some folks said you could use 2 booleans, one of which was called undergoing maintenance, which was true or false, and one of which was called available for hire, which is also true or false. That would kind of work. There's kind of like a weird state if you do that, where it's both undergoing maintenance and available to hire because they're both true, which is a little bit potentially confusing. But as long as you put in your answer something along the lines of it's going to be a thing which goes in boat to tell the world what kind of state the boat should have, I'm a happy bunny and it all just works. So the thing I wanted there was basically some data which lives in the boat class that says what the state of this boat is. Lots of objects in lots of systems are stateful. Sprites in video games can be alive or asleep or whatever. Bank accounts can be open, closed, whatever. Everything you make pretty much has a state, and this question let you show that you know how that works and how to do it. So great, another 5 easy marks. The boat hire system always is. This is the one that I think caused the most mental whirring of gears during the exam, because there are no right answers here. There's just lots of different ways you could do it. We've got a customer and a boat hire class, and what I want you to think about is what kind of stuff you put in those classes and how we'd represent the fact that a boat had been hired. It was 6 marks, so it wasn't really vastly important to get completely correct. But what I was really after here was something which let me find out that a customer was linked to a particular boat. And in real life, the way you would do this is to actually have a customer class which contains, I would do something. Let's go into C# and start a new project, and I'll save this one. I'll just give it the name Exam Fun, slap it in there, and then we'll make one called, I'll put that on the web as well so you can have a look. We'll make it called Jolly Boating. Okay, and then we'll just make that, and then we'll make ourselves a class called Boat, and that will have stuff in it, and we can also make ourselves a class called Customer, and that will have stuff. And everybody spotted things like he's going to want to have his name and probably his address and probably his payment details. And so everybody got that bit, and that's fine. That's what you're going to sort to customer. That's fine. So the fun and games come when you think about the class, which we can call boat hire. Okay, right. So what's this going to have in it? Well, it'll probably have the date hire start, and it'll probably have a date which is hire end, I would think, and this is the thing that you need to have. It'll probably have the customer. You can think of a better name for this, but I'm going to call it customer who hired the boat. And when we have a boat, that's how I would do it. So my customer contains all the stuff about customers that you'd like, and my boat hire it's the technical name for these things, and we'll do it next year, is called an association class. It's a class that defines a relationship between two things. You could have what called marriage, which had basically a link to two people who were married, and possibly the date of the wedding and the name of the vicar, and the total value of the gifts given at the reception, and even the text of the speeches from the best man, if you like. But basically, it will be a class that defines an association between two other classes. Okay, boat hire does that. Boat hire says, okay, this is the person that hired the boat. This is the boat that was hired. And so what I would tend to do in my system is I'd have a whole list of these things that are all my hirings. Now, a lot of people did stuff that was kind of close to this. They had customers that contained links to the boats that they'd hired, and they had boats that had links back to customers that had hired them. And that's all absolutely fine. So the key thing when I was looking at your answers for this one was, is it possible from this customer when in your system to find out what boat Fred has hired? And is it possible from your system to find out who has hired boat X? Now, in my little design, I have a list of these things in my system, and so I can work through and find out which boats are where. Some people put the name of the boat in there. That's fine. I'm using reference to the objects themselves. That's fine. But we know the boat has to have a name, and so we could put the name of the boat and the name of the customer. That's fine, as long as there's a way of linking these two together, as long as it's navigable, to use a technical term. So anything which allowed you to link the boat and the customer gets you your 6 marks. And on we go with the question. Ooh, abstract. Lots of people did a really good job on this, because lots of people said the word template at this point in the conversation, which is a great word to hear, because a class which is abstract is effectively a template for child classes. Lots of people said you can't make an instance of a abstract class because they are abstract, they're purely a template, and lots of people say that the child classes provide the real behaviors in the methods that go underneath. So you'll be overriding methods in the children to provide proper versions which reflect what they want. And in terms of examples, people came out with bank accounts or stock items, where the stock item is abstract, and then we have different types of things in stock. Quite a few people even mention boats, which is fine too. There's no reason why the boat class in our previous part of the question can't be abstract as well. And some people said yeah, bank accounts, which can have child accounts and credit card accounts and what underneath them. So basically that was another good 6 marks or so of family fun. And I think that takes us to the end of question 2, and then we move on to question 3. Oh, I've got an email. Isn't that nice? I have a point. Supporting SharePoint governance. Ooh, that sounds good. Mustn't fail to miss that. Okay. Question 3. C# code below is part of a bank application. Well, I like banks. Banks are good. Well, I used to like banks a lot more than I do. Anywho, lots of different objects, accounts, statements, and invoices, all of which we have to print. Each of the objects will provide a header string, which is going to top of the document, and the string which contains the text. So if you think about a bank statement or a letter, dear Mr. Miles, please can we ask you to clear your account overdraft? All these things are going to have a header at the top, and then some text which is actually the body of the letter or whatever's being printed. So that's fine. The programmers have gone ahead and made us a interface called printable document, printable document, and they've been sensible. They've given it a capital I as the part of the name, and it contains 2 method headers, and the question says for eight of your Earth marks, explain how C# interfaces can be used to address this problem and what would happen if the account class implements the above interface. Okay, right, so what do we do? Well, in these situations, the best thing to do is to go back to the problem. I'm going to make a new project. I'll save that one, and I'll call this one account interface, just to fiddle with, and then we'll save that. I think I may have, and so yeah, make another console application, which we'll call account. I may have got that wrong. I may need to fiddle with some stuff a little bit later. Accounts. Let's just call this accounts. Oh dear, never mind. You should never type with an audience. This is what you should never do. So in here, I'm going to make myself a class called account. I'm just going to go like that, actually. No, I'm not. I'm going to go back into here. I'm going to copy that code. I'm going to go back into here, and I'm going to get myself an interface. And then I'm going to go class account. Now, I can say to the universe that I actually implement this interface by doing that, and then I've actually got what's in the question. Now, unfortunately, you don't have access to a Visual Studio System Junior exam, which is kind of sad. Maybe you should ask for that. Ask the please, can I have a Visual Studio, please? And another marking book. May not go too well, but this will help me illustrate what I want you to talk about in terms of what happens. If I do this and try and build the program, then it complains. The compiler is complaining because, quite frankly, I've lied to it. I have said that the account class can be asked to print itself, because that's what iPrintable really means. And the way you would ask the account class to print itself is to call one of these two methods. Okay, so I've said the account class can print itself, but I haven't put the methods in. If you were looking at getting good marks for this one, you basically, what you have to do is provide a tell me that the account class must hold these methods because that's what we're after doing. Okay, so the account class is going to be, when you call it, it will actually return a string. We give it a string, not sure what that's for, but we give it a string, and then it returns something. And then we do the same thing. Yeah, we do the same thing for the, and it returns a string here. And then, now the string is simply a way the printer can tell the account things like paper size, where you're going. We don't really have to use that too much, but I can actually get document header here as well. And then in here I go, this is the header for the document. And then now, if I now build it, it'll compile. So in terms of answering the question, if a class implements an interface, what it means is that the class must contain copies of the methods that the interface asks for. A lot of people said things like an interface is like a CV, or a sort of a list of promises which a class can make. And that's going to get you good marks. That's the right thing to say, because this is basically a list of promises. It says if I implement the interface, I've got a method you can ask me to get the text of the document, and a method you can ask me to get the actual header for the document. And so I can effectively now make myself an account and ask it to print itself. And lots of people also pointed out that once I implement an interface, you can talk about me in terms of that ability and not what actual type that I might be. So in here I can go iPrintable document something. If I could type something, that would be better. Equals new account. Okay, so something is a thing which you can print. Actually, it's an account, but now I can go something dot get document text, and I can ask it. I don't know, A4 page if you like, and I can actually now go call that method and get the text. So I can go console.writeLine, like that. So I can ask the actual thing to tell me about itself, and away it will go. But I'm not treating this as an account. I'm treating it as a printable document. So if I now run the program, put a breakpoint there, this should all work. Wouldn't that be nice? There you go. Have a little look, see what it said. This is the text in the document. Yeah, okay, because what's happened is that it's called that method on the account. Now, if I had an invoice or a statement or any other class, I could make it implement the same interface, have its own versions of getDocumentHeader, and then it could then print itself in the way that it knows and loves. The key takeaway from this, the most important thing to take away really, is that an interface doesn't actually do anything. The interface itself doesn't have any behavior in it at all. The interface is simply a list of promises, things that I say I can do, things that I claim I can do. Okay, so it doesn't actually have any behaviors. Some people said the interface will do the printing. No, it won't. The interface just contains a placeholder which can be used by whatever implements the interface to do that job. Okay, so if you said all those things, then you were absolutely tickety-boo, and you were going to actually get yourself the marks. The key thing really is this: what would happen if the account class? What would happen is it would have to have a getDocumentText and a getDocumentHeader method, because otherwise it would be lying to the compiler. And if you lie to the compiler, then really bad things will happen to you and your program. And so that's kind of how that all fits together. Okay, second part. I think we're into XAML country now. Explain with an example how the XAML markup language. One person took exception to the phrase XAML markup language because the M and the L there mean markup language. It's extensible application markup language is what it's actually called. But I couldn't think of a better way of putting the words in. So for that I apologize, but basically deal with it. I don't care. In terms of what I was after here, it was you telling me that what happens is you have a bunch of text that tells you whereabouts on the screen the buttons, the text boxes, the list boxes, the grids all go. And the markup language is basically a thing which declares where all these things are. One or two folks said a declarative language, which is kind of fair enough. It doesn't actually have any behaviors. It just says we've got a button here, a text box here, a label here, a list box here, blah. Okay, so anything which went along the lines of we use this thing to design our user interfaces, it's all text, it's all designed to be human readable, and you can actually put things on the screen by editing this stuff, is going to get towards the 7 full marks on this. If you went along the lines of Visual Studio lets you edit this stuff and fiddle with it and all that kind of good stuff, then that takes you up towards that 7. So, and if you put in a little piece of XAML with some less thans and greater thans all lying around and things like button or text box, then that's the example. Please bear in mind, if I ask for an example, then it's kind of best if you provide one. So when it says explain with an example, what I really want is an example. So do the best you can with that one. But that was basically a straight piece of bookwork. And if you'd had any truck with the exercise where we converted crazy timers from a command line program to a graphical one, if you can remember that far back, anything along those lines would have got you your 7 marks. And I think that's, for me, that's pretty much it. Well, thank you for listening. If you have listened, I have no way of knowing either way. I hope it was useful, and I hope you get the marks that you're expecting. And with that, I'm going to go have a coffee and try and lubricate my voice a bit.